Hello and welcome back to the 44th Annual Internationalization and Unicode Conference. This is Session 7, Track 1, International Languages and Regional Locales. My name is Joel Celine and I am the Globalization Architect at Domo Incorporated, a SaaS business intelligence company headquartered just south of Salt Lake City, Utah. I will be presenting today on behalf of the entire Domo Globalization organization, all four of us, and I want to thank you in advance for taking the time to watch this video. I hope you find it informative and useful. As the title of this session suggests, what I want to talk about today is the conceptual distinction between an international language and a regional locale. More specifically, I want to talk about the implications of this distinction for software internationalization and localization, and preview some of the work we are doing at Domo to add support for regional locales to our business intelligence platform. For the sake of time, I'm not going to discuss our reasons for adding regional locale support, or spend time trying to prove that the conceptual distinction between an international language and a regional locale corresponds to an actual distinction that exists out there in the real world. Instead, I'm going to start by simply defining how I am going to use the terms international language and regional locale in this presentation, and then provide a few real-world examples that illustrate how the concepts these terms refer to differ. Having clarified the conceptual distinction between an international language and a regional locale, I will then go on to describe how this distinction manifests itself in a software internationalization and localization design pattern we call regional formatting. I will then show how we have tried to implement this pattern in our new JavaScript Internationalization and Localization framework, I18N Locale. As you will see, this framework actually works by leveraging the differences between an international language and a regional locale, a fact that allows us to support a fairly large number of regional formatting conventions, 29 in our case, using a much smaller set of internationalized language resources. After going over the basics of regional formatting and introducing I18N Locale, I will do a couple of short demos that showcase what the I18N Locale framework is capable of, and then conclude the presentation with some closing remarks about the relative advantages and disadvantages of using the international language and regional locale distinction in software internationalization and localization. We have a lot of ground to cover, so let's get started by talking about what is meant by an international language. For the purposes of this presentation, I would like to define an international language as a language or linguistic system that is commonly used as a primary or secondary language in more than one geographic region. International languages are sometimes called macro languages, but I prefer to use the term international language because I believe it better highlights the fact that the language in question is used in more than one place. A good example of an international language is English. English is international in the sense that, while it may evidence certain regional differences, its different forms are all mutually intelligible to people who speak English, even if they are in different parts of the world. An example of a non-international language would be Japanese, since, to my knowledge, Japanese is only used as a primary or secondary language in Japan. International languages are typically the result of some kind of large-scale movement in human history. For example, something like colonialism, empire, emigration, or diaspora. Because of this, international languages often have original, base, canonical, or dominant versions, as well as secondary, derivative, local, or minor versions. In many cases, the different versions or forms of international languages have differences in things like pronunciation, spelling, style, vocabulary, and so on. There may even be small grammatical differences between some forms, but in general, things like plurals, ordinals, and gender tend to be the same across all the forms of an international language. From a software internationalization and localization standpoint, localizing an app into an international language has the advantage that it allows you to cover a lot of territory and support users in many different parts of the world. Eventually, however, you have to deal with the fact that certain items outside language proper can be quite different in different locations, and this brings us to the concept of a regional locale. In simple terms, a regional locale is a geographic region or territory in which, among other things, one or more languages is commonly used. Regional locales are often tied to particular political and socio-economic bodies, for example, nation-states, and they often fit, or have artificially been made to fit, within the borders of a particular country and its territory. In part because of this, regional locales often have their own national conventions for formatting things like numbers, dates, currencies, lists, and so on. These conventions can be implicit, but are usually explicit, and in many cases they have actually been codified into national regulations and laws. From the standpoint of software internationalization and localization, supporting regional locales and their regional formatting conventions provides a much more local user experience, which in turn makes it easier for users to do the things an application is supposed to help them do. At the same time, though, supporting regional locales and regional formatting conventions can make the process of internationalization and localization much more complex, and depending on how you do it, considerably more expensive. There is, however, an easier and cheaper way, one that actually leverages the distinction between international languages and regional locales and uses open source libraries and data to minimize translation costs. At Domo, we think of this method as a software internationalization and localization design pattern, and we call the pattern regional formatting. In this section, I'm going to go over the basic elements, relationships, and operations that make up the regional formatting design pattern, which we will then see implemented in the next section in the I18N locale framework. There are 6 basic elements in the regional formatting design pattern. The elements have certain relationships with each other, and these relationships allow them to perform certain operations and functions. One way to understand the regional formatting design pattern is to think of it in terms of a kind of blueprint or recipe for creating regional locales with unique formatting conventions from internationalized language resources, CLDR locale data, and open source locale-aware formatting and parsing logic. The first ingredient you need to make a regional locale is some kind of agreed upon way of identifying and referring to different locales and languages. Fortunately, there is an existing standard for this, IETF RFC 5646, which is better known as BCP 47. The nice thing about BCP 47 language tags, as they are called, is that they support varying degrees of specificity, allowing you to define a hierarchy of tags, like the one found in the Unicode Consortium's Common Locale Data Repository, or CLDR. This is important because once you have defined a locale hierarchy, you can then write, or even better, borrow an algorithm that filters or resolves a BCP 47 tag against a list of supported or available tags and returns the best fit or match for the specified tag given the available options. With locale resolution in place, you can define a very specific regional locale tag, for example ZH Han SSG, and resolve it down to the tag for the corresponding international language, for example, ZH or ZH-S. This is useful because locale tag resolution allows you to main just a small set of internationalized language resources and programmatically access them using more specific regional locale tags. If we combine our internationalized language resources with some region-specific CLDR locale data and some open-source localization, formatting, and parsing logic, we end up with a very powerful but fairly complex system that speaks internationally but formats values according to region-specific conventions. Because this system is so complex that only an experienced internationalization engineer would really understand how to use it, we need to finish things off by wrapping everything in a simplified, locale-oriented internationalization API, that is, a facade. Having such an interface makes it easier for ordinary web developers to produce complex applications with regional locale support, and do so in much less time than would otherwise be required. In order for the regional formatting pattern to work, the elements described on the previous slide need to have the right properties and relationships with one another. Language resources, hereafter messages, must be international in style and tone and kept free of any region-specific formatting. The data, on the other hand, needs to be as region-specific as possible in the sense of as close to the actual conventions of the regional locale you are trying to create as it can be. Since your international language resources may be spread out across multiple places in your code base, and you don't really need all the region-specific data CLDR provides, you need to provide some kind of regional locale build system that produces the message and data bundles capable of being consumed by the Internationalization API and or the localized formatting and parsing libraries. These bundles must be tagged with the appropriate language or locale so they can be retrieved programmatically when needed, and locale tag resolution must be used to find the right messages and data for a particular region. As is often the case, only when everything is properly connected and coordinated can the operations that need to be performed in a way that produces the desired output. This brings us to the operations or processes associated with regional formatting, which are listed here in roughly chronological order. The first operation is to build the message and data bundles, without which nothing else would work. These bundles must somehow be installed into the Internationalization API and kept in a place where they can be accessed by tag without overloading application memory. Since regional formatting is a per locale pattern, there needs to be an initialization process in which a locale capable of accessing the internationalized messages and the region-specific data is created. Once a locale is created, using it is either a matter of calling accessors to get messages and data, or passing messages and data into the value formatting and parsing logic. For the sake of ordinary developers, the Internationalization API needs to provide simplified public methods for all its retrieval, formatting, and parsing functionality. And since we are using a locale-oriented instead of a format-oriented approach, these methods must specify both the type of value to be formatted and the format according to which the value should be processed. Although it can be difficult to remember what a particular name format looks like in a particular region and language, choosing from a vetted canonical list of formats, in my opinion, is still much easier, though arguably less powerful, than configuring a bunch of separate format objects for each format you need. And the locale-oriented nature of the regional formatting pattern makes this locale object portable in the sense of being capable of being shared between application components. Now that we've gone over the regional formatting pattern and outlined its basic elements, relationships, and operations, we can turn to look at the JavaScript implementation of this pattern in I18N locale. The I18N locale framework is actually a combination of 6 internal and 1 external NPM packages, with some of the packages being direct or peer dependencies on others. I would like to eventually make this framework open source, but that depends on whether there is enough external interest to justify the extra effort. The main packages in the I18N locale framework are I18N locale CLI and I18N locale, both of which have dependencies on I18N locale util. I18N locale CLI has additional direct dependencies on I18N locale message provider and I18N locale data provider, while I18N locale, the runtime interface, has peer dependencies on I18N moment and message format.js. All of the internal packages have been written in TypeScript and then compiled down into ECMAScript or CommonJS modules. The I18N locale framework is a modern JavaScript framework in the sense that the runtime interface is intended to be used in conjunction with webpack, and the CLI can optionally produce specialized webpack index files that enable lazy loading of messages and data. Let's take a look at the I18N locale packages in the order they are listed here. I18N locale util is a static class with static methods designed to handle BCP47 locale tag resolution and other locale tag related functions. The resolution logic uses locale tag validation and locale tag canonicalization, but the validation and canonicalization functionality can also be accessed independently. The utility uses BCP47JS for locale tag parsing. It's bundled into the package, but it can also compose a valid canonical locale tag from an object of the type BCP47JS produces. Finally, the utility includes a localize method that can insert a supplied BCP47 tag, or any of its subtags, into a string using placeholders like locale or language. Having this functionality is necessary for loading messages and data, but it can also be useful by itself to help localize file paths or URLs. The I18N locale utility is a direct or peer dependency of all the other I18N locale packages, and all of the static methods of I18N locale util are exposed as static and public instance methods in I18N locale. The I18N locale message provider is the tool we use to create I18N locale message bundles. Its constructor takes an output tag, an array of input tags, and it has a single public instance method get, which takes an array of bundle objects, each of which must include an I18N locale utility compatible localized file path or pattern, and can include an optional name for the bundle. If no bundle name is provided, the contents of the resources loaded by the provider are put at the root of the outputted message module's main element. Because it loads bundles using an array of bundle objects, the provider can support loading resources from multiple places in a code base. And when you call the provider's get method, it reads the resources in each of the specified bundles for each of the input locales, and then merges all the resources together into a single message tree. Resources are merged from right to left through the input tag array, so that less specific locale resources are overwritten by more specific locale resources. This makes it possible to create override files for regional locales, that only include the strings that need to be different from the base locale. In this way, the provider supports regional locale-specific messages that are applied over the top of international language messages. The provider outputs a messages module with tag and version that can be installed using a static method on the i18n locale class. The tag is set to the specified output tag, while the version is set to the package version in the i18n locale CLI configuration file. The i18n locale data provider is the CLDR analog of the i18n locale message provider. It is responsible for loading CLDR data from CLDR JSON files that are installed as dependencies of i18n locale CLI. The data provider's constructor takes a single BCP47 tag, which is resolved against the list of available locales in CLDR JSON, the modern edition. It also has a public get method, which takes a filters object with optional locales, currencies, and unit fields. These fields map to arrays of locale tags, currency codes, and simple unit names that determine which locale display names, currency names, and unit names and patterns will be loaded by the provider. If no filters are specified, all of the available data is loaded. Similar to the message provider, the data provider outputs an i18n locale data module that can be installed using a static method. The module is tagged with the resolved CLDR locale tag and versioned with the CLDR version. Significantly, the data provider translates CLDR JSON's date, time, datetime, and available datetime formats to moment.js syntax. Moment.js is what Domo uses for its legacy internationalization, and it provides both time zone support and the ability to pass formatting skeletons into the format method. The i18n locale CLI package provides the command line interface used to initialize, clean, and build an output directory with optimized i18n locale message and data bundles. The CLI reads options from a .i18n locale configuration file, which specifies the name, version, locales, bundles, filters, and build options for the project under development. Initializing the build directory is optional. Doing so creates the directory if it does not already exist and puts an index.js file at its root that exports a getI18n locale method. Using this method requires having built and indexed the data and message directories inside the output directory. Messages and data can be built together or separately, and each directory can either be automatically indexed via a configuration option or using the command line. The indexes in question are kept in index.js files at the root of the messages and data directories. They include a data structure with locale tags and bundle names that map to webpack dynamic import statements. The getI18n locale function uses these indexes to lazy load the message and data bundles for a particular locale. The function returns a promise containing a fully configured i18n locale object with messages and data preloaded. By passing an array of bundle names as the second argument to getI18n locale, you can load just the message bundles you need for a particular part of your application. Most of the formatting in i18n locale is done inside the i18n locale class itself and is custom to the framework. The exceptions are date, relative time, duration, and message formatting, which are handled by i18n moment and message format.js respectively. These packages are peer dependencies of the i18n locale package and must be installed along with it. The I18N moment package exports a copy of moment.js and moment time zone specifically configured for Domo and I18N locale. The API is exactly the same as moment, but it adds the 1970 to 2030 locale data and only defines the locales needed by our application using moment's parent locale functionality instead of entering all the information for each parent and derivative locale separately. This minimizes code duplication and results in a smaller overall package. Domo has used message format for message formatting for several years, and we have been very happy with it. We configure message format to ignore strict plural key checks because we merge internationalized language files, and we enable BiDi support. We don't currently use the BiDi support, but we have included it for the sake of future-proofing. The final part of the I18N locale framework is the I18N locale package itself. You use this package by importing the class and passing a valid BCP47 tag to its constructor. This creates an I18N locale object and sets the messages tag and data tag properties of this object by resolving the tag passed in against the list of tags from the installed message and data modules. The messages tag is, as you might expect, used to retrieve messages, which can then be passed to the format message method that handles ICU syntax message formatting using message format.js. Data is retrieved with the data tag and is mostly used internally by the formatting, parsing, and display name methods. The data in each locale object includes display names for languages, regions, currencies, and units, as well as the patterns used to format values such as numbers, currencies, dates, times, durations, units, and lists. Relative time is handled entirely by moment.js and is exposed through the format relative time and from date or to date methods. Supported number formats include standard, long, short, and percentage, while supported currency formats include standard, long, short, and accounting. Dates, times, and available date and time combinations use formats derived from CLDR and translated into moment.js syntax. The names of these formats are taken from the elements they contain. Durations can be expressed in years, months, days, hours, and seconds, while relative time supports both calendar and unit expressions. Units have long, short, and narrow formats, while list formatting combines these formats with and, or, and unit types of lists. Finally, locale names can be formatted in standard, separator, and key formats, and these formats work with both the current locale display names and the specified locale autonyms. The framework can parse standard decimals and standard dates, and it supports all the input formats moment.js does. To get a better sense of what this framework can do, let's look at a couple demos I put together for internal purposes. This first demo is designed to showcase I18N locale's formatting and parsing capabilities. First off, you can see I have a locale selector in the top right-hand corner, and this selector lets me switch the formatting widgets between different locales. The locales are represented in the selector by their autonyms, but they could also be represented by their current locale display names. If I start typing some digits into the number formatting widget's input field, I18N locale will take those digits and format them using the different supported number formats in the list below. The same is true for the currency input, but I can also switch between different currencies and enter a negative number to show how the accounting format works. For unit formatting, I can specify both the amount and the type of unit, and for list formatting, I can specify the standard and, or unit list types. The relative time, duration, and date formatting widgets all use i18n Locale's date parsing capabilities, and this parsing is supported across locales. Relative time can be expressed in units and in calendar expressions, while durations automatically adjust for the amount of time being considered. In the date formatting sections, you can specify a date and then specify a time zone and watch the resulting date formats change. The table below the inputs lists the cross-locale names used to reference the different formats and shows both the skeleton used in formatting and the resulting formatting string. As noted earlier, these formats are taken from CLDR and translated into message format into moment.js syntax. i18n Locale took a long time to put together, longer than I care to admit, but after it was built, it was possible to put together this entire demo site in less than a day, and much of that time was just getting the CSS styling right. This demo was created to show how easy it is to set up an internationalization project using i18n Locale and the i18n Locale CLI. But it also shows the difference between the regional formatting options i18n Locale supports. If I go up here to the locale selector, you can see that not only does the language change, but even within a language, there are changes in formatting for dates, numbers, units, and messages. Furthermore, by passing in the time zone identifiers for different cities that are somehow associated with these different locales, we can then show the date and time in different parts of the world. Finally, if you look closely at the locale selector, you can see that while the select options use autonyms, if you hover over an option, you get a small tooltip giving the name of the locale in the current locale's language. This is important for international accessibility, but also useful for international testing. Although the second demo is relatively simple, it demonstrates things the other demo did not, and so I wanted you to see it as well. Now that we've looked at the demos, let's wrap things up by briefly discussing the advantages and disadvantages of using the international language regional locale distinction in general and the implementation in i18n Locale in particular. The chief advantage of i18n Locale, in my view, is that it provides an easy to set up, easy to configure, and easy to use internationalization and localization solution that any competent web application developer can understand. Furthermore, because i18n Locale is both locale-oriented and runtime independent, the locale object you create can be passed as a property to any UI component, and it will always work the same in any browser. i18n Locale provides developers with a full suite of formatting and parsing options and gives developers access to localized display names and autonyms they would not have access to otherwise. Finally, because i18n Locale uses moment.js and message format.js under the hood, it handles plurals, time zones, and time zone conversions well. The main disadvantage of i18n Locale is its size. The complete framework is between 85 and 100 kilobytes gzipped, but most of that is actually time zone data, about 60%. Once an alternative to moment.js's way of handling time zones is available, the size of the total package could be cut down dramatically. As noted at the beginning, using international languages in software internationalization and localization tends to gloss over important regional differences, And while IETN locale addresses this for formatting and parsing, it still uses international languages for messaging. This disadvantage can to some extent be ameliorated by adding locale-specific message overrides, but the process of doing so requires extra work, and in most cases it is probably not worth the effort. For some international languages, like Portuguese, the dialectical differences between two versions of the language may be significant enough to warrant doing some kind of pivot translation between the two variants. In most cases, however, the international languages are mutually intelligible enough to just be left as they are, provided the regional formatting conventions of the particular locale are respected. With that, we have come to the end of this presentation. Thank you again for watching. If you have questions, comments, or suggestions, there may be time at the end of this session to address them. If not, you are welcome to contact me via email, and I will do my best to address the questions to the extent that I am able. Enjoy the rest of the conference, and please submit your review forms if and when those become available. Once again, this is Session 7, Track 1, and the title of the presentation is International Languages and Regional Locales. Goodbye for now. I hope to see you all in person next year.